We're going to start the session now. As I had mentioned earlier in the group, I'm going to go through the EDA part first. So because this was an assignment for you guys, so I believe you might have researched on some of the things you should have done. But for me, I'll take you through this EDA part first so that you can understand some of the things we look at when we are dealing with data. So this is weather data. So for the next class, we might use another type of data set. So let's kick off the class. So what I'll do first is I'll start by importing libraries. So I'll import pandas library. Then I'll import numpy, matplotlib, seaborn, datetime because we have a datetime column. And then I'll import warnings to ignore all warnings. Yeah, so these are the libraries we are going to use. So we have pandas, numpy, matplotlib, seaborn, datetime, and warnings. So as that is running, I'm going to type in the code here to read in my CSV file. So we are going to have our data being equal to bd dot read underscore CSV. Then I need to check my file name. So this is the file name. So what I'll do is I'll type in Seattle dash weather dot CSV. So that's my data. Then we can have data.head to see the top 5 rows of my data. So that is running and it's going to take a few minutes to do so. As that is running, we can go through the data description and see what are the details that we have here. So about this file, or about the data. So explore the intricate climate patterns of the Emerald City within the Seattle weather dataset. So dive into a comprehensive collection of weather data that unveils the city's renowned reputation for rain and its ever-changing atmospheric conditions. So from this data description, we expect the majority of days. So for the majority of days, we are going to have rain. So uncover seasonal trends, precipitation variations, and temperature fluctuations. So all encapsulating the unique charm of Seattle weather. Okay, so let's see if my code has run. So this is my code. So what we are going to do is so I've got some extensions here. So I'm using Visual Studio Code. I've got some extensions here that I can use to wrangle this data first. And what I'm going to do first of all is check my data. So this is my data. So if I check here, we have 1461 unique values. So if I check the date column, we have 0 missing values. Then for precipitation, we have 0 missing values. We have 111 unique values. Then here you can see the distribution for precipitation. So we have a higher count here where we have values from 0 to 3, 3 to 6, and 6 to 9. Then when it comes to values from 6 to 9, then 6 to 57, the count is low. Then for temperature, you can see temperature is a little bit normally distributed from these output that we have here. So when you're working as a data analyst, so you need to have tools that can assist you in doing your analysis fast because you don't have to spend much time having to like visualize these things, but we are going to visualize them in our data set. So this is just an extension I'm using. Quickly go through what we have in our data set. We have the minimum temperatures, we have wind, which is normally distributed. So for all these columns, we don't have any missing values. Then here we have the weather. So we have 5 unique weather conditions. So we have rain, sun, fog, other. So I don't see the fifth, so we'll have to investigate and know what the fifth is. But the fifth is drizzling, if I'm not wrong. Okay, and you can see rain and sun are somehow same, have a same distribution. So we have rainy days occupying 44% and sunny days occupying 44%, then fog and other 5%. Okay, so yeah, we can go with that. So this is a date column. So let's see if we can change the column type. Yeah, so this is a date column. So we are going to change this column from date. But a minute, so let's go back to our code and see what kind of data we are dealing with. So what I'm going to do is I'm going to type in data.info. If I check the data.info part, you can see this date column is an object. So we need to convert it to a datetime object instead of us having an object. So if I select maybe the first value of the date column, so data, then I pick the date column, then I pick the first value. That's what we get. And if I check the type, so you'll get to see that this is a string. So if I go back to my preprocessor here, so I can convert this column here to be a date column. So I'll click on apply. And then if we go back to our data set, that code should be there. Or let's add the code here because I'm going to share the code with you and I'm not going to use the data wrangler. Okay, so what I'm going to do here is change the date column to date time column. So we are going to have data, then we select the date column. Then we are going to have pd.to underscore datetime. Then we are going to convert the datetime column to be a date. Then we can run that and you can see if we check the time, the type, this is a Python timestamp. So if I extract the first value, then that's what we have. Okay. So that's it for the date column. So I guess that's the only pre-processing we are going to do here. But before we proceed, what I'm going to do is I'm going to extract the hour. So I'm going to extract the hour, day, and month from the date column. So we don't necessarily need the year column because I think we can extract the year column also because we might need it for modeling part. So this is just for modeling and it's not part of EDA. So this is just part of the pre-processing. So we are going to have data hour and this is how we extract the hour column. So I believe you were shown these during the intro to Python programming. So how you work with datetime columns. So that's what we have. And if we check our data now, so if we run data.head, this is what we get. So we have the date column, we have the precipitation column, temperature max, minimum temperature, wind, weather. We have the hour, day, month, and year column. So actually we don't need the hour column because it's not present here in our date column. So let's delete the hour column. I'll remove it there because we don't really need it. Then I'll go ahead and I'll import the data again. Yeah, so that's what we have. Then let's now do the EDA, exploratory data analysis. And the first thing I'll start with is I'll investigate the target column. So I'll explore. the target column, or let's say the target variable, which is weather. So first of all, let's check the value counts for each and every weather type we have there. So here we have rain, 641, sun, fog, drizzle, and snow. So I guess there is a part where we can say normalize being equal to true and we get percentages. So rain takes 44%, sun takes 44%, fog 6%, drizzle 3%, and snow 1%. So you can go ahead and maybe create a pie chart for that. So here we are going to have our figure, then we do our pie chart. So let me change this to code, and then we should get our output. Let me reduce the size of this figure, and then we should have that. Then I should add that semicolon for us to remove all the texts that are there. So this is a pie chart showing us how the different weather conditions are distributed. So first of all, we type in plt.py. Then for our data, we pass in the value counts. So which is this part here. Then the data labels, we extract the unique values from our column. Then we add this auto percentage here, which shows the percentage of our pie plot, and then we add some additional features there. So that's our pie plot there. So let me format this code to be a little bit neat so that you can see everything that I've included here. So I've saved that. Another thing we can do is we can do the distribution of all these the columns. But for now, we've already seen the distribution of all these columns, so I won't repeat that. And basically, you know how you can create the distribution plots. So what I'm going to do here is I'm going to create a function for you guys to use. So I'm going to create a function for you guys to use to plot the distribution for the numeric columns. And this will be def distrib dist plot, and then this will be the function. So this is the function to plot the numeric columns. So you pass in your data and your column name as variables for your function. And then we can try it out. So first of all, we pass in our data and we pass in the temp column. So if we run that, key error temperature is not present. So let's check the temperature maximum, or let's take the wind column and see what kind of distribution do we have for the wind column. And if we run that, you can see what we get. So this is the distribution that we have for the wind column. Yep. So my fixed size is a little bit large, but at least it accommodates some of the things you need to see from your data. So that's it just for the basic EDA part. So I've shown you some of the things we can look at for this dataset. So the next part we are going to look at is the machine learning part. And as I had mentioned, so for this part, I'll go slow and you can follow through. So you can open your notebooks from where you left off your work. So I believe you have this dataset. So the only thing you don't have is this part for changing the date column to be a date time and extracting the day, month, and year from that date time column. But let me share this code in the chat section. So from your work, I need to like give you 5 minutes. Copy this code and create the date time column yourselves also. So that should take you 5 minutes to complete, and then we can head over to the machine learning part. We do it together. So remember, we are working with logistic regression, and that means we are dealing with a classification kind of problem. And for this classification task, for our target column, we have 1, 2, 3, 4, 5. We have 5 different targets. So we'll get to see how our model handles that. And then from there, we are going to look at something else, which is the, what should I call it? So it's the unsupervised learning models, but I guess we'll look at that tomorrow. So 5 minutes at 8:24, we proceed. So run your codes again and now customize the date column to be a date time object and then extract the day, month, and year from that column. Okay, so I guess we should proceed on and let's continue from down here. So for those who want to create distribution plots, so you can use these function that I've created here to do that. So this should be more better so you can see the bins even clearer. Yeah, so let's proceed on. So this is the machine learning part. So first of all, I'll type in my data.head and get to see what I'm dealing with. So first of all, we have the date column. So I won't be needing these anymore because already I've created the day, month, and year column. So I'll have to drop this, but before I can drop that, so let's create so I'll create a time series plot of the temperature, for example, or let's create a time series plot for the wind and see what we get. So here you can see how the winds change. So for the first few months of the year, the winds are usually high. Let me export these to a new tab and then we can zoom in a little bit and see. So if you check these, we basically have a few months here where the winds are really high and a few months where the winds are low. But you can explore that later and maybe document your findings. So that's the time series plot for, so this should be wind. So you can do the same for all the other columns and see what changes. Okay. So yeah, let's proceed on. So this is our data. So when fitting machine learning models, so the first thing we
Excuse
mentioned,
me, Joseph.
yes,
How did you get that? What is the code for that distribution?
this distribution here,
Yeah, not that one.
this time series plot.
Yes, time series.
Yeah, so it's just a line plot with the date on the x-axis and the wind uh, data on the y-axis. And then these are the labels. So yeah, maybe you can have like 2 minutes, copy that, and then we can proceed. Then here I'm setting the fig size. The most important part is this one here.
Please share the code in the chat box.
Okay, let me do that right now. Yeah, you can copy the code. I've shared it in the chat box. Okay, I guess we can proceed. So here, what we are going to do is we are going to start with step 1. And step 1 is to split the data into the features and the target variable. So we are going to have our x being equal to data.drop, and then we are going to drop the weather column because this is our target column. And then again, we are going to drop the date column because when fitting machine learning models, so this will cause issues. So we can't like fit timestamps into our models. And that's the reason as to why I extracted the day, month, and year column from my data. Then our y will be the weather column. So that's what we have. And then if I check my x, that's my x. So maybe x dot head. Then we can have the first two values. That's my x. Then we can have y dot head two values. That's my y. So you can see what we have. So go ahead and replicate these, and then we can proceed on to step number 2. So who knows what step number 2 is? So step number 2 will be importing the machine learning library we are going to use and maybe going ahead and fitting our model. So what we are going to test for today is, can we fit our model while these values are not encoded? So we are going to confirm if that is possible. Yes, Almasi?
I just have a request.
Yes.
If I feel you're going too fast, most of these things are new to us.
Oh,
So,
so like which one?
like, okay, just starting from the machine learning part, you have not yet really got grasped it. You know, for you, I think you're used to it, so you're just writing the codes fast, explaining fast.
Yeah, so I'm giving you time to copy the machine learning code part. So hope that's the case. Hope I'm not going fast here. So for the EDA part, I completed that part fast. But for this step, I'll be giving you time to run the codes. So
Not just running the codes, like explaining.
yeah,
Yeah.
yeah, but you can be asking questions if you have any. Yeah,
Okay.
okay. So let me re-explain this. So for the data.drop part here, so anyone else with a question? Yes, Brenda.
Yes, my code stopped working
Yeah.
the moment we started doing the conversions of the year,
Yeah.
changing the date to the other codes are not running.
So maybe try restart your Jupyter notebook and see if it might work. And then rerun all the codes. Did you get any errors while running the code to convert date?
When I was doing the exercise by myself, me, I didn't know that part was supposed to do the conversion. So me, I just worked with the data the way it was.
It's okay, it's okay. So, yeah, this is a new thing I've introduced to you, so you should learn from what I've done. Yeah. So, when I shared the assignment, so I just wanted you to like go through it on your own, then compare what you've done to what I'm going to do today, and see if you had an idea as to what maybe could have been done. So you've got till 8:36 to try copy this code and then we can proceed. So let me share this in the chat and then I'll explain it. So we have the data.drop part here. So that's just some part of the basics of pandas. So pd.drop, so we can search that. Yeah, so it's a pandas method. So you use this to drop columns that you don't need. So first of all, you specify the columns that you want to drop, then the axis, then the index and all that. So that's basically what I'm using instead of me using the square brackets method, because I can only select the columns that I want, but that would mean I'll have to include 1, 2, 3, 4, 5, 6, 7. So I'll have to include a square bracket here with 7 values, which will be a little bit tiresome. But for the target column, I use the square bracket method of indexing columns and I extract only the weather column as a series. Then here you have x.head to see the top 2 rows of your features and y.head to see the top 2 rows of your target variable. So 1 minute, then to complete the code, then we can proceed. Okay, so I guess we can proceed on to step number 2. So step 2 in this case will be splitting the data into training and test set, but for me it will be fitting the model. So we are currently discussing the logistic regression model, which is for classification. So we will do that before we go into unsupervised learning. So tomorrow we will finalize the introductory to machine learning part. Then we will head over to advanced machine learning 1. Okay, so let's proceed on. So here we are going to import the logistic regression model. So from sklearn.linear model, import logistic regression. So what you need to note here is L is capital and R is capital. Then after that, we are going to instantiate our model. And then we are going to have our model being equal to logistic regression. So instantiating the model means we are creating, so this is like a function. So a function that will do some calculations in the backend. So some calculations that maybe we discussed in the theory part. And these calculations will be able to like predict if it's going to drizzle, rain, or be foggy or something like that. Then we are going to feed the model to our x and y. So x, so here we have model.fit, so this variable that we've instantiated here. So another approach will be to write something like logistic regression, then dot feed x and y. But I will not maybe encourage you to use this method, so just follow what I'm showing you. Then after that, we are going to step 3, which is making predictions. But before we go to step 3, so we should run this and see if we are going to get an output or if we are going to get errors. Because I believe we've not encoded the target column. So what I want us to confirm is, should we always encode the target column or can we leave it as it is? So if it's classification, in most cases, we can leave the target column as it is without us having to encode it. Okay. So what we are going to do lastly here is make predictions. So we are going to have our ypred being equal to model.predict x. And then step 4 is to evaluate the model. So we are going to print the accuracy. So I don't have to include all these text here. So I'll just type in model.score and then that should give you the model score. So this model has a 78, the model is 78% accurate. And basically we are done creating our model. So these are the steps you will usually follow. So the first step is importing the library that you are going to use. Step number 2 is instantiating the library. So creating a variable called maybe models. So in this case, I'm using model. So you can use LR, you can use any word that you think is fit for you. Then you feed the model. So you're going to have model.fit, then x, y. So x being your features and y being your target variables. Another thing you need to note is the size for x and y should be similar. So if I run in something like x.shape, then y.shape, you can see we have similar number of rows in each case, but for the number of columns, it doesn't matter because what we are doing here is basically using these 7 features to predict this single value here. Okay, so you know the code for y.shape. So let me give you 5 minutes to do the code for this ML. To complete that ML part, then we can discuss some few things that we've done today. So by 8:45, you can copy the code by 8:45, then we can proceed on from there. Okay, so hope everyone is done and maybe we can summarize. So for the summary, what I'm going to do is I'm going to add the predictions to the data frame. So we are going to have data then predictions being equal to ypred. Then we can check maybe the top 20 rows. So we can have data dot head. Then we can check the top 20 rows and see what we get. So this is what we have. So we have the first observation here. So I'll give you a chance to copy this code or let me share it in the chat section. So what I want us to look at is what are the outputs we are getting here. So for the first observation, which we have here is the weather. The weather was drizzling, but what we got here was sunny based on this observation here. So this is the prediction that we made. So we predicted that the day will be sunny while it was drizzling. Then for observation 2, it was rainy. We predicted rain. Same for this, rain, rain. So up to observation 6, all our predictions are correct. Observation number 7, our prediction is correct. Observation 8 and 9, 10, 11, 12 are correct. Then here where we have the cases for snow, we are predicting the weather to be rainy. So how can we know that maybe for each variable if we are predicting them to be correct or not? So what we usually do is we create something called a classification report, but we will discuss this in detail in another class. But I want to show you guys how you can create a classification report. So from sklearn.metrics, we are going to import classification report. And then what we are going to do is we are going to print the classification report. So we pass in our correct values and our predicted values, and then we get such kind of output. So with this output, we are going to see how correctly we predict some of the variables we have here. So if we check this classification report that we are getting here, you can see that for drizzling, we have a prediction accuracy of 0%. So it means that this model, don't expect this model to predict any day to be drizzling, because you can see here from the precision, recall, and F1 score all have a 0 value. So we will discuss precision, recall, and F1 score later on in the course, and I'll explain to you guys what they mean. And here you can see the same thing happens for fog days. So for fog days, you can see the precision is at 0%, recall is at 0%, and F1 score is at 0%. So this means that when it comes to fog and drizzling days, we won't expect our model to predict those days as being foggy or drizzling. And same applies to days where we have snow. So this model won't predict if a day will snow or not. So what this model will do is it will predict if a day will be rainy, and the model will be 86% accurate on that. And it will also predict if a day is sunny, and the model will be 81% accurate when doing that. So any questions concerning what we've looked at? So let me share this code in the chat section and you can copy it and we will discuss it later on. So we will discuss the classification report later on, and maybe how is the classification report generated. So we need to know the calculations that are done for us to come up with this kind of output here. Yeah, so that should be all for today. So you can copy the code that we have here for classification report, and maybe you can ask questions if you have any. So I'm going to give you till 8. So 8:53 should be okay.
Just a have a question here.
Yeah.
Oh, I've seen when you are doing the target
Yes.
variables,
Yes.
you didn't, or rather before the subset, I didn't see you allocating the code binary, the one that you 1 or 2 or 0, you didn't allocate like the one that we did for, the last class.
Yeah. So, yeah, what I was saying is for today's class, we are going to do some few tests and we are going to see if us not encoding the target variable has an impact on our model. And what we've seen is if you are creating a classification model, so for the target column, it's not a must you encode that column. So your model will be able to like make predictions if you encode or even if you don't encode the target column. But when it comes to the features, so what is inside X? So anything that is inside your X should be encoded, and that's the reason as to why I removed the date column, because this is not numeric. The date column is a timestamp, as we saw here. So I converted the date column from being an object, which was a string, to being a timestamp. But from that timestamp, I extracted the day, month, and year. And then we were able to fit a model with only numeric features. Yeah, so hope that's clear. So the target column, if you are fitting a classification model, it's not a must you encode it, so you can just fit it as it is. Okay, clear. Okay, so I'll resend the multiple linear regression video. So I'll check to confirm if it has audio. Okay.
Hello. Good evening. Okay, on my end, the way I approach the data, I tried converting which sector? The weather sector into from categorical to numeric. Does it mean that I was totally wrong? Okay, and then another issue I got when handling the data, I misspelled something. Then it gave me an NA. I rectified the mistake, but still I got errors going forward concerning that. Mm, mm. Okay, thank you. I also saw that you did not upload the data, this data for weather, to your drive. You just worked with it from downloads. Now, me, I'm trying to run still. I have a challenge converting, changing the date column to date time what? Date time format. From when I ran that code is when I started getting errors. Yeah, it is.
Yeah, she can also check whether she has imported the data. I had the same issue, but I had not imported the date as DT. Yes.
Okay, okay. I did not.
Okay, so as we end the class, I'm going to show you maybe one of the powerful models we usually use for classification and regression. So this will be just an extra part. So this will be fitting a random forest model. So random forests are much more better when it comes to fitting classification models. And I'm going to evaluate the model and we are going to see the kind of accuracy we are going to get for a random forest. Then I'm also going to print a classification report and see if it will take into consideration the other weather condition, which is drizzle, fog, rain, drizzle, fog, and snow. So this model is 100% accurate in predicting all weather conditions that we have here. And actually what you can do is you can go ahead and replicate this and see if that's the case. Yeah, so remember, as I had mentioned, this is the introductory part to machine learning. So I'm just showing you some basic models here in the introductory part. One of them being linear regression and logistic regression. So after we are done with this, so when we start the advanced machine learning one, I'm going to show you models such as the random forest classifier and the other better models. So from there, you'll get to see how machine learning improves with us using better models. So you can see random forest has an accuracy of 100%, whereas the logistic regression model had a 77% accurate model. And it wasn't predicting the drizzling, fog, and snow weather conditions. So let's see if random forest does that. Yeah, so if it is drizzle, then it's drizzle. If it's snow, then the prediction is snow. So yeah, from these, I believe you now understand what machine learning is all about. So it's using data that is there to like come up with predictions. So what we can do is we can extract this model that we've fitted here and use it to like predict what kind of weather we will have tomorrow based on the readings that we are going to get from our weather station. Yeah, so that's all for today. So what I'll do is